Okay, today we're going to be dividing polynomials. Before we do that, let's just use regular numbers. If you remember dividing in elementary school, maybe you learned, you got this kind of like symbol here, and you go, which one goes on the house? In the house, so it used to be 13 goes in here, and the number you're dividing by goes out here. And if you remember, like 5 goes into 13, how many times? 5 goes into 1, how many times does it? 5 goes to 13. I guess that'd be 2 full times, so 10. And then if you remember, you always subtract what's in that second row. 13 minus 10 is 3. 5 goes into 3. Well, it doesn't really go into 3. And so that's where I know we could go to and get a decimal, but we're just going to stop and remember what some of these terms are called. So um, this one's probably the easiest, right? The 3 is your remainder, if you remember. We just called that the remainder. Um, The divisor is what we divide by, if that makes sense. So divisor would be 5. The quotient is kind of like our answer minus the remainder. So 2 is our quotient. The dividend is probably the hardest to remember, is the number we're dividing into parts here. So the dividend. Okay, so that idea is important because I want you to write this down in your notes. I want to have this, the form of our answer is going to be the quotient plus the remainder divided by the divisor. So for example, if this was our question, which we're not just using numbers, the answer would be 2 plus remainder is 3 divided by 5. So 2 3/5 is our answer. And that actually is the answer, right? 2.6 or 2 3/5 is the answer to this problem, actually. Okay, so let's go to the harder problems. So in this case, we're going to do long division here using long division polynomials. So similar setup here. So we're going to divide this. It's a little bigger kind of house thing you draw there. So x cubed plus 4x squared minus 3x plus 2. And then we're dividing by x minus 1. I know that's kind of weird. It's a binomial, but we're dividing by a binomial up there. So first, let's just start with we're start multiplying. So you really, and what's weird is you look only at the first term. So x goes into what? Just like we did here in this one, we first were going 5 goes into 1. Well, in that case, it didn't. In this case, it does, right? X goes into x cubed how many times? X times what is x to the third? And I hope you would say x squared. Don't put x squared up above this because I'm keeping this vertical column here only for x cubed terms. So the next column is for x squared terms. So I'm going to put the x squared term directly above the other x squared term. I try to be very organized. In this section, it's kind of extremely important that you do organized work. So if you remember how you got like this 10 to put down there, you did 2 times 5 to get 10 to put right there. So we're going to do the same thing. X squared times x is x to the third. That's to the third power. And then x squared times negative 1 is minus x squared. So I multiplied, essentially this was multiplied by both of those terms, x squared multiplied by both. Put it in the row below, and we're going to subtract everything in that row. So when you subtract, I might distribute this, right? So when you distribute, you can see you really, that first term goes away, it always goes away. 4x squared plus 1x squared is a total of 5x squared. If we're bringing down the next term, we're going to have to bring that down. So minus 3x. Okay, so now let's look at the first term here and the first term here. So x goes into 5x squared how many times? X times what is 5x squared? So it looks like x times 5x is that. So I'm going to put that in the x column. So it's a positive 5x, so I'm going to put plus 5x up here. If it was a negative, I would put minus 5x. And again, this term is being multiplied by both of these terms. I put it in the row below. So 5x squared, that always matches. minus 5x. And again, I'm going to subtract both of those terms. And so that's going to distribute here. So that's a negative and that's now a positive. So the first term goes away. Negative 3x plus 5x is positive 2x. Don't forget to bring down the next term, which is plus 2. Okay, look at the first term, x and 2x. X goes times what is 2x? That would be plus 2. Multiply that by both terms there, so 2x and minus 2. Really hopeful this goes away, but I'm not sure. So I'm going to distribute, it becomes positive. And so I get that 2x goes away. 2 plus 2 is 4. Oh, unfortunately, I have a remainder of 4. So my quotient is that. So my answer is x squared plus 5x plus 2. That's my quotient. Plus a fraction. 4 is a remainder divided by my divisor, which is x minus 1. It's hard to read that. That's a 4. And that's my answer. So those two terms did not divide nicely into each other. Sometimes you'll have a remainder of 0, and if you did, you have found a factor if that's the case. But that's not the case here. If the remainder is 0, it's a factor. This is not a factor. It doesn't divide nicely. I'm hopeful this one's going to be a factor, so just kind of trust that it will be. So let's set it up here. So we get this big house here. So this is 8x cubed plus 6x squared minus 29x plus 15. And this is the binomial 4x minus 3, which is our divisor. Okay, so 4x goes into 8x cubed. Let's see how many times. 4 times 2 is 8, and x times x squared. So that'd be 2x squared. So I'm going to put that in the x squared column. So 2x squared is going to be 8x cubed. Multiplied by the next term, that'd be minus 6x squared. That's unfortunate. Okay, so we're going to subtract. Don't forget to change the signs there. Okay, so when we do that, we get 6x squared plus 6x squared is 12x squared. I thought it might go away, but it didn't. Bring down the next term, minus 29x. So 4x goes into 12x squared how many times? Let's see, 4 times 3 is 12, x times x is x squared, so that'd be 3x. So plus 3x, I think that's positive. I put it in the x column here. So we get 12x squared, no surprise, that matches, minus 9x, okay. And subtract, don't forget to change the sign when you distribute. Okay, so the first term goes away. Negative 29x plus 9x is negative 20x. Bring down the next term, so plus 15. Getting close, almost there. So 4x times what is negative 20x? So 4 times negative 5, so minus 5 is my next term, so negative 20x should match. Plus 15, ooh, that's good. I kind of like this. Let's see what happens. Just subtract, don't forget to distribute the negative. And you get negative 20x plus 20x is gone, 0. 15 minus 15 is 0. The remainder is 0, which means this is a factor. So my answer is 2x squared plus 3x minus 5. Now, if you ask me to multiply this times this, guess what we would get? Yeah, those are both factors. 4x minus 3 is a factor, and 2x squared plus 3x minus 5 is a factor. So this is kind of hinting at what we're going to use this for. You might be like, why are we learning to do long division of polynomials? Because we're going to be able to factor things like this if we learn how to do this method. So, because it's really hard to factor that actually. but we're going to learn how to factor it using long division with some other techniques we're going to learn as well. So be very orderly. If there's a missing term, I don't know if you see it, but there's a missing term here. And actually, this is supposed to be x right there. Sorry about that. I don't think I just mistyped it or whatever. But there's a missing term here. What I mean is it goes from, I kind of expected another term right in here. Do you see where it's missing? Right, I went from x to the fourth to x squared. It's like I skipped over the x cubed term altogether. And then I go from x squared to x to constant. That all makes sense. X squared to x to constant denominator, that makes sense. But there's no x cubed term. So when I write this out, you'll notice I'm very careful to keep things super organized. So I'm going to put 8x to the fourth plus, I want to put 0x to the third. That's my missing term. It's going to keep my work organized, and it's going to keep you from making mistakes, hopefully. It's easy to make a mistake doing this stuff. And wow, we're doing a trinomial now. We just keep stepping it up. So we're dividing, our divisor is a trinomial. Okay, so we've got 2x and 8x to the fourth. So 2x squared, so 2 times 4 is 8. X squared times x squared is x to the fourth, so that'd be 4x squared. I'm going to put that in the x squared column. So 4x squared. Multiply that by all three terms there. I get 8x to the fourth. That's good. I like that. Minus 4x to the third. That's why we have that placeholder there. It'll help keep our work organized. We wouldn't have a place for our x cubed. We'd have to be, it'd get confusing. Minus 4x squared. And don't forget, we've got to subtract all of those terms. So I'm going to distribute that negative. This first term goes away. Add up those. I get 4x to the third. Let's see, plus 10x squared. Bring down the next term, minus 31x. Look at the first term here, 2x squared times what is 4x to the third? That would be 2x, so plus 2x, it looks to be positive. First term always matches, it's 4x cubed. 2x times negative x is minus 2x squared, and plus 4x. We're going to subtract everything there. So I'm going to distribute that negative. And we get, first term goes away, 12x squared minus 35x, and then bring down that last term, plus 1. Okay, getting there. Getting close. So 2x squared times what? So that would be 2 times 6. So that'd be plus 6. So that'd be 12x squared. 6 times negative x is minus 6x. And 6 times 2 is plus 12 there. So I'm going to, don't forget, you're going to subtract everything in that row, just like we always do. I'm going to distribute that negative. Okay, let's see what happens. I think we're going to have a remainder. So negative 35 plus 6 is negative 29x minus 11. So my answer is 4x squared plus 2x plus 6 plus the fraction negative 29x minus 11 all over 2x squared minus x plus 2. And it's quotient plus remainder divided by divisor. Sometimes the problem looks kind of weird, and so you might just need to be aware of this. When you see something like this to a negative exponent, that brings it down to the denominator. It's called a reciprocal function, so 1 over x to the negative 2 is 1 over x squared. So I'm dividing by that. So I get 2x cubed minus 7x squared. Hopefully you see this. Plus 0x. It's missing a term there, so I just put it in. Plus 5. And then we're dividing by x minus 3. So let's look at the first term here. So we get x times 1 is 2x to the third. That would be positive 2x squared. So we've got 2x cubed. That matches. It's good. Minus 2x squared times negative 3 is negative 6x squared. Whoops. So we're going to subtract everything there. When you do that, forget to distribute. Confusing myself here. Okay. Okay, so first term goes away. We get, well, that's not too bad, negative x squared. I guess I'm going to bring down the plus 0x here. So let's go to the next one. X times what is negative x, so minus x. Okay, so we get negative x squared plus 3x, plus because negative 3 times negative x there. We're going to subtract, which means we're going to distribute that, and that's going to become a negative 3x there. So first term goes away, of course. 0 minus 3x is negative 3x. Bring down the next term. It's the last term, so I know we're about done. And let's see what happens here. So we get x times what is negative 3x? That'd be minus 3. So we get negative 3x plus 9. I'm going to subtract both of those. Distribute that. So remember, okay. Almost there. We have a remainder, so it's going to be 5 minus 9 is negative 4. So that's our remainder. So my answer is 2x squared minus x minus 3 plus a remainder of negative 4 divided by a divisor of x minus 3. You could either say that as plus negative there, or if you'd rather just say this as subtract that fraction, that would be okay as well, since it's definitely a negative 4 there. And that's our answer. So that's how to divide with long division. We'll learn a shortcut tomorrow that works on some of these problems, which is kind of a neat shortcut, but that's enough for today. You're going to practice long division on your homework tonight.